And welcome everybody to the Daily Space Weather. Today some interesting cosmology stories to cover, as well as a change in the NOAA forecasts for the incoming coronal hole wind stream and associated geomagnetic storm. And lots more to cover here at the Smash News Network. By the way, I'm your host, Dan, aka smAsho. Also, the filament and coronal mass ejection we were talking about yesterday has remained in the corona. So we'll show you that momentarily here as well. What we're looking at here is the 171 angstroms and colorized magnetogram view from the SDO. And the filament that we were talking about yesterday, which appeared to be erupting, has not indeed erupted. And it's right down here. You can see a little bit of activity right there. And that is what we were looking at. We weren't expecting it to be Earth-directed. But it's actually still, it's either collapsed back into the corona or onto the chromosphere, or it's suspended someplace else at a different portion of the sun. And we'll show you more in depth into that right here with the view at Lagrange point 5. So Lagrangian point 5, that's where stereo A is located, one of the points of gravitational equilibration. And here's the view from stereo A. So from this perspective, Earth would be off to the right. And just to help you visualize that, there it is again. You're looking in this direction from stereo A at Lagrange point 5. And we can see this bit of plasma right here, which still could be in the process of erupting. So this is what we were expecting to see leave the corona yesterday. It's still there, so the probability of coronal mass ejections is up a little bit, and we will keep you posted on that if it does indeed release and what sort of direction it's headed. Here's an even better view of this eruptive behavior here in the southeast. And again, we think that has actually not ejected at all, but instead remained suspended in the corona by the sun's magnetic fields. And there are some filaments in around this area. And likelihood of major solar flares isn't really that high. Likelihood of coronal mass ejections is up a little bit as a result. Here's the last 24 hours in 304 angstroms. The best wavelength at showing you filaments. And we'll show you an animated view of the filaments later in the video. Here's a diagram of the solar system. There's where things will be in a week. And by the way, we'll be streaming live tomorrow at the moment of the vernal equinox, or if you're in the southern hemisphere, the autumnal equinox. Which I believe, according to Smash staff, is at 5:37 a.m. Eastern Time tomorrow morning. Here's a star chart. And if you're up before dawn, you may see a planetary pileup rising ahead of the sun. Let me bring up the sidebar to advance this. You may see Jupiter, Mercury, and Saturn, as well as Venus, all rising ahead of the sun. Saturn first, then Jupiter, then Mercury, and then just barely ahead of the sun, Venus, if you've got a clear sky and a view of the eastern horizon. The radial flux all the way down to 73. And the 10.7 centimeter radial flux is the closest stat that we have to sunspot number, discovered in 1947 by some Canadian radio engineers who were messing around with some World War II radio equipment, noticed the 10.7 centimeter radial flux, and it's been recorded ever since then, 1947. This top line here, this black line, is the 10.7 centimeter radial flux. And the red line underneath it is the sunspot number. That's 1 year. To put that data in context, you can find that at solon.info. And here's the big change to NOAA's forecast here. NOAA has changed the forecast for early tomorrow morning for the geomagnetic storm all the way till late tomorrow night and early Sunday morning. So they've moved up the timing of that, and that actually seems a little bit more logical to me. We could see a pretty significant geo-effective situation from this geomagnetic storm. This coronal hole is quite a significantly sized coronal hole, and there is quite a bit of electron content available between the sun and the earth right now. Without getting further into that, here's the LASCO C3 as Venus continues to swing around toward the backside of the sun. So when we're talking about coronal hole wind streams, we're talking about mainly solar protons, hydrogen nuclei, from that area right there, that large South Pole-oriented coronal hole system. This is the 193 angstroms view from the SDO. Another one of the ionized UV emission spectral states of iron. Yes. And I think we've got a close-up of that coronal hole as well here. Here's the close-up of the southern hemisphere in that same wavelength. And I don't know why it's not on loop. And next, let's talk about volcanoes. First, let me check the life of the stream here. Excuse me. And we see Etna expected to erupt again. There's a view of the new southeast crater. So 14 paroxysms with an interval about 2 to 2.5 days. We're expecting number 15 to be coming at any moment. Mount Abico also erupting, 10,000-foot ash plume there. Cinnabung, 10,000-foot ash plume as it explodes. Dacono also exploding. Flight level 070 at Dacono. Vendiaminoff, no explosive eruption there on the Alaskan Peninsula. However, explosive eruption in central Mexico at Popocatépetl, producing a 19,000-foot ash plume. Pacaya in Guatemala exploding as well, 11,000-foot ash plume there. Volcanic ash not observed in satellite at Fuego in Guatemala. Please do not pole vault the caldera. Revenador also exploding. Flight level 140 over the Ecuadorian volcano. It's a 14,000-foot plume of volcanic ash, and intermittent emissions of volcanic ash at Sabancaya are a reminder to not pole vault the caldera. Today's featured product is the Do Not Pole Vault the Caldera socks. One of my favorites. This will be actually, I think, my next piece of merch that I pick up. As we cyclists, especially ones who wear team kits, we are limited to the clothes that we can wear, so I'll be wearing some Do Not Pole Vault the Caldera socks coming up soon. You can find links to that at smAsho.com. By the way, we've also updated the forum, and I would announce a new video series coming, the Corona Chronicles, where we'll use this forum thread to examine where we were a year ago and where we are now regarding the pandemic, as the sword of Damocles hangs above all of our heads because reasons. And again, if you head to smAshomash.com, you can find links to the forum as well as the Redbubble shop, where you can find the Do Not Pole Vault the Caldera merch, as well as some other products. Go check that out. Again, you can link to all of that at smAshomash.com. Let's go to the seismicity over the past 24 hours. Largest earthquake of the past 24 was a 5.7 in China. It was in China. That earthquake was made in China. I don't know if it was a cheap plastic, cheesy, intellectual capital stolen earthquake or if it was a legit earthquake, but probably an earthquake based on technology stolen from the U.S. Okay. China. A cheap Chinese 5.7 magnitude earthquake. Okay. So we saw a deep quake in Afghanistan, only a 4.4 magnitude, but over 200 kilometers depth. And we're just going to scroll up the list here. Oh, we see two very, very high altitude quakes here. This one at 2.4 kilometers above sea level. I'll bet it's directly underneath the Mauna Loa caldera. And not so direct. It's under the eastern flank of Mauna Loa. You can see it's quite a few miles there. Something like maybe 7 miles to the east underneath the main caldera. Again, the depth of that quake is negative 2.4 kilometers, 2,400 meters above sea level. Also, we saw 3.1 at 1,600 meters above sea level. That one in a similar location there, the eastern flank. So some motion in the lower lava tubes here. Will a new caldera form? Also another quake. So these three happened all within a period of about half an hour. The 3.5 was at 1823 Universal Time. The 3.1 was at 1827 Universal Time. And the 2.5 was at 1850 Universal Time. Here's the location of the 2.5. That one also on the eastern flank of Mauna Loa. So some magmatic activity there. Also another 2.6 at 1,800 meters above sea level. So some significant, extremely shallow quakes. So shallow that they're well above sea level. There's a 2.8 at 1,500 meters above sea level at Hawaii on the main island. Also a 700 meter above sea level quake. So that's a significant uptick there in extremely shallow quakes at Hawaii. 1,000 meters above sea level, a 2.5 magnitude. A deep quake at the northern Mariana Islands, a 4.6 magnitude at 123 kilometers. Here's that 5.7 in China, just to the northeast of India. There's a location of that. Looks like a pretty mountainous region there. Probably not all that populated. Actually on the Tibetan Plateau. And we saw a couple come in as we did the show. Continuing on, back with some solar data here. No major solar flares over the past 24. Here's the 3-day chart of the GOES X-ray flux. Again, no major flares, and the likelihood of major flares has gone down as Sunspot 2810 has degraded a bit since yesterday. Here's the proton flux over the past 3 days. No surprises. We don't see any spikes there. We would have probably let you know ahead of time if there was a coronal mass ejection. The GOES magnetometer over the past 3 days. Fairly smooth here. Keep in mind there is a coronal hole wind stream on the way, so you're going to see this jump around quite a bit over the next couple of days. Here's a visualization of the heliospheric current sheet, showing you the polarities there. South pole oriented in red, North pole oriented in green. Keep in mind the data is 1 hour and 31 minutes old. The Earth will be solidly in the South pole current sheet for the foreseeable future. Next, we'll show you the line of sight coronal hole plot, and you can see that large red blob there. That is the coronal hole that'll be providing the geomagnetic storm conditions most likely in about 24 to 36 hours. And here are some more little data points on the sun. Only one sunspot, 2810. It is alpha class. I don't know. It's showing beta class there, but it's not beta class. It's totally alpha class, and it's been alpha class. Also, we see some filaments up here in the northwest and around the eastern limb. And this one in the northwest is the one that we're looking at the possibility of seeing erupt. That's what we were talking about in yesterday's thumbnail and title when we said coronal mass ejection unfolding. That one stayed suspended in the corona, as we showed you earlier on the stereo A imagery. So we see a Gradual uptick here in the solar wind density over the past 14 hours. Current solar wind density just below 11 protons per cubic centimeter. Current solar wind speed only 311 kilometers per second. Expect to see this approximately doubled when the coronal hole wind high speed portion shows up in 24 to 36 hours. KP index currently at 2. That's a measurement of global geomagnetism. And if you're a new viewer, thanks for tuning in. Here's 4 hours of magnetosphere data. It's all based on the Space Weather Modeling Framework, and it's courtesy University of Michigan Geospace Model V2.0. You're looking at magnetohydrodynamic pressure measured in nanopascals. And expect to see this light up when the geomagnetic storm strikes. Let me advance that to where it was. We don't want the video to be too long. And we'll also show you ground magnetic perturbations, geospace delta B. In other words, changes in the Earth's B field. So here is the polar view. And we're currently living through a geomagnetic excursion where we have two North Poles and the South Pole is someplace south of Australia, as opposed to anywhere near the South Geographic Pole on the Antarctic continent. It's way over here somewhere, nowhere near the South Geographic Pole. And here's the global view. Changes in the Earth's B field. Not a whole lot of geospace delta B here. And this does give insight into where we're likely to be seeing auroras happening and stuff. Very minimal amount of auroras expected to be seen right now. By the way, this video is streamed live to Twitch. Thanks to our Twitch viewers. It's twitch.tv/smAsho. It's a fantastic live streaming platform as gamers lead the way in many aspects of computing. By the way, if you don't follow me on Instagram, you may not get pics like this. Instagram.com/smAsho. Thanks to our new and not so new subscribers over at YouTube. Please don't forget to press like and subscribe. If you enjoy the content, tell your friends, your foes, your science noobs, and science pros about the channel before it vanishes entirely, along with the entire Smash News Network, and becomes pay only. We're also on BitChute, thanks to our subscribers over there, as we approach 400. And let's do a cosmology segment. Now, here at the Smash News Network, we recognize cosmology as kind of important, as there are aspects of the physical sciences in the process of being rewritten, and some that should be rewritten. We're trying to advance all of that. So let's talk about complex carbon molecules. Well, there's a cold cloud of dust known as the Taurus molecular cloud, and it's not even believed to have any stars in it. So how do we get all of those complex carbon molecules in there? Well, it's not known, but it's interesting to see the signal of all of these aromatic hydrocarbons. So talking about chemicals such as I don't memorize the names of chemicals. But we're seeing chemicals there such as benzonitrile, cyanonaphthalene, 1-cyanonaphthalene, 2-cyanonaphthalene, benzonitrile, and other complex aromatic hydrocarbons. And spectroscopy is one of the very interesting aspects of space, as we don't know how these things are there. Is it part of some sort of Generation 2 star system? Well, we really have no idea. PAHs, polycyclic aromatic hydrocarbons. And you can find this article on phys.org if you want to read that. It's in the astronomy and space section. Today we're not going to be picking any random numbers from our quantum dice throw. We're going to be talking about NGC 253. Why? Because last year on tax day, a magnetar from within this radio galaxy, and it's an X-ray source too. We're going to show you the view on X-ray as well. This is actually infrared light on the 2 mass. Here's blue light, which will show some additional features there. And here is the view from Chandra. And we're going to zoom in on the galactic core here. The view from Chandra. The Chandra X-ray telescope, showing us some interesting features here. Some evidence of jets and so on, located around the core of galaxy NGC 253. And there's a magnetar in there somewhere. Now, magnetars are a type of pulsar which has a very strong magnetic field. And sudden perturbations in that magnetic field can release gamma ray bursts, which is what you're seeing an artist's rendition of here. And there was an interesting gamma ray burst that swept through the Milky Way galaxy and indeed our own solar system last year on the 15th. So this was detected in all kinds of different instruments as this swept across the solar system. And this was an important gamma ray burst. So this event was known as GRB. I don't remember the name of it. GRB 2004 or something or other. GRB 200415A. So believed to be a sudden rearrangement of the magnetar's magnetic field, possibly caused by a starquake, but since these objects aren't really understood, we don't really know what caused it, but for some reason, an object in NGC 253 sent a 10 million year old, I think it's at about 10 million light years. Geez, what is the distance of NGC 253? I have no idea. But in any case, there's an interesting article here on SciTech Daily about this particular gamma ray burst. And one of the problems with gamma ray bursts is it's tough to figure out where they came from. And that diamond there is that's the area where the gamma ray burst likely came from. So that portion, sort of the northern portion there of NGC 253, is the region from which that gamma ray burst emanated. Again, that's just an artist's rendition of a magnetar there, folks. And that was a giant gamma ray flare. So an interesting article here on SciTech Daily. If you'd like to have a read there, scitechdaily.com. Article entitled, NASA Spacecraft Unmask High Energy Blast That Swept Through Solar System Magnetar Eruption in Nearby Galaxy. Although it's not really that nearby, NGC 253 is actually at a couple million light years, I think. I just can't seem to find the distance to that galaxy. But in any case, have a read on the article if you haven't. Again, it's at SciTech Daily. Also, an interesting one here about the jets from stars. So an interesting one here also on phys.org's astronomy and space section. Torrential outflows from infant stars may not stop them from growing. Once again, the phenomenon of how stars are born is not understood, but there's a bunch of activity coming from these. You can see some, likely a bow shock right there, a thing that looks similar to a pulsar wind nebula there. So some great images there from Hubble. And this is from phys.org in the astronomy and space section. As the poloidal field jets from stars carve out sections of empty space around them on the regs, And these things are emitting jets of gas similar to the sun, or similar to most stars, indeed, have poloidal jets. And when the sun's fields align to its jets, we call it solar minimum, as we see enduring coronal holes at both poles of the sun. And without getting further into the weeds on that, let's continue on to talk about another jet-producing area. It's Centaurus A. So this must be the strongest radio source in the galaxy Centaurus. And this one is quite visually interesting as well. And you can see this is probably actually similar to the Milky Way galaxy, which is now believed to be a warped disk. And what we're seeing here is the offset of the jet. So some galaxies, the jet is perpendicular, in which case it would be more like in these shapes. But we see this jet is offset by a significant, maybe 20 or 30 degrees offset there, where the jet is coming out not perpendicular to the plane of the galaxy at all. And you can see these Fermi bubble-like areas of X-ray emission right here. Those are associated with the jet as well. It's probably the precessional wobble of the galactic core. And if you're wondering what precessional wobble is the wobble on the axial tilt of all rotating objects, like a top, or like the Earth, or like the Sun, or like indeed the Milky Way galaxy. All of these spinning objects precess. Anyway, that's a great view there in multiple wavelengths. You can see visible, X-ray, infrared, and radio, all in this composite image of galaxy Centaurus A. Also, I would note that there is a relationship between the torus and the poloid. So the torus, the toroidal field, is the donut-shaped field that would be around this area. The disc-like field around the equator, and the toroid field would be these large conically shaped fields coming out of the poles. And there is a proportional relationship between those, in that when we see greater emissions from the torus, this donut-shaped field in the middle, we see less emissions from the poloid fields. And when we see more emissions from the poloid fields, we see less emissions from the torus. An indication that there is some sort of a proportional relationship there, and I won't get further into the physics of that. We don't want the daily space weather video to be too long, and this cosmology segment is integrated into the daily space weather video. That's today's cosmology segment. Let's move on to some more data, such as the realm of electron flux. Here's the 1-year chart. Don't take my word for it. You can find it yourself at solon.info/solar. The 1-year chart of the relativistic electrons surrounding planet Earth at the F ionosphere layer. So here's the GO-16 measurements over the past 3 days. And our patrons would be well aware that we were at about 6 times warning levels here yesterday. Don't worry, it gets all the way up to about 30 times warning levels when we see legit electron storms. Current situation is we already see the electrons tanking a bit here, sparked by that increase in the solar wind density. So here's the forecast model, and you can see the green boxes are expecting a dip in the electron flux over the next 2 days. I would tend to concur with those forecasts. The yellow diamonds are the observations. Here's a visualization of the entire air column. This will show you where GPS error is most likely to occur, which is typically around the equator at noon. No real surprises there in the total electron content. And this is just a visualization of the Van Allen belts. And what you were just looking at there, the total electron content forecast, is approximately 12,500 miles of altitude from where a GPS satellite would be through the inner Van Allen belt to your GPS handset. Keep in mind this shows distances in miles. Here's just the ionosphere, a visualization of that. This is at about 300 kilometers of altitude, where the GO-16 endeavors to make its measurements. And I'm seeing this for the first time, so let me just take a look here. Some minor anomalies here over South America once again, I would say. Here's the latest image, which is from 9:15 Universal Time, looking normal at that moment. And here's another diagram of the atmosphere. The F layer right here is where that visualization comes from. The F ionosphere layer, where the GOES 16 makes its measurements, we show it daily. As well as this, feel free to pause if you need to look at that longer. Now we're in meteorology realm, looking at the jet streams of the Western world, which are quite meridional in nature. When you see the jet stream flowing north and south instead of east and west to east, that would be meridional jet stream flow. And what you see right here is straight up backwards jet stream flow. It's pretty minor, though. Jet stream in the southern hemisphere, at least in the western part of the world, is looking quite kinked, as we see some 180-degree bends there, and a powerful anticyclone centered over Scotland. Here are the jets of the eastern world, I think. Here are the jet streams of the eastern world. And we see some extreme meridional jet stream flow here in the southern Indian Ocean. Let's take a look at surface winds real quick. And back to 250 hectopascals to show us the jet streams. Here are where pressure cells are located. I would note low pressure over the entire south geographic pole. The whole bottom here is blue. That's all low pressure. And we'll advance this. This is the Euro forecast. Here's where we expect pressure cells to be at 12 noon Eastern Time tomorrow. Whoops. There we go. There's 12 noon Eastern Time. High pressure dominating the entire eastern portion of the U.S., probably making for clear skies. Windy.com is a great mobile app also, by the way. Now we're on blitzortung.org to see some significant lightning here off the east coast of the U.S. I don't see any U.S. terrestrial lightning. We'll stay zoomed out. And you see these straight lines here. That is the equinox, which is tomorrow around 5:30. 5:37 Eastern Time, I believe, is the time of the equinox. And we will be streaming live to YouTube, youtube.com/smAshomash at the moment of the equinox. So join us for the exact moment of the equinox during tomorrow's YouTube exclusive live stream. Next, looking at the cloud layer. And you see that major area of clouds there moving northeast into the North Atlantic. Here's the water vapor map as the atmospheric pond is pushed out by some cold air dipping in from Canada and some dry, warmer, more massive air coming from the south, combining around a place like Maryland. And here's a U.S. Doppler radar map as the remnants of that moisture move their way out. Some snow falling in Pennsylvania here. It looks like north of the Blue Mountain, most likely is the demarcation line there. And quite a bit of precipitation in the Pacific Northwest, as well as places like West Virginia, and western portion of North Carolina there. Thanks to our patrons, a true source of funding for the content. Please consider becoming a patron. We gave patrons some additional perks just last night. Did you like the wallpapers and animations last night, patrons? Patreon.com/smAshomash if you want the earliest warnings and so on. Again, patrons are the true source of funding for the content, as we make just this side of nothing to make the content on YouTube. Next, we're going to show you the bonus segments where we're going to feature here at the Smash News Network the colorized magnetogram. So here's what I saw when I did show prep. So there's Sunspot 2810. There are the magnetic fields. And you can see it's an alpha class sunspot. I don't know why it was saying beta class sunspot on the Integrated Space Weather Analysis Center. So we're going to press refresh here. And we'll show you how this has evolved. And it looks like it's degraded further, actually. So we're seeing a weakening here in Sunspot 2810. Here are some additional views. This is the 193 angstroms view. Small coronal hole there associated with the North Pole, also rotating in the Earth-facing zone. Probably won't see any coronal hole wind stream from that at all. Active region in the northeast. In the northwest over here. Not a sunspot. The only sunspot is 2810 right now. And we'll also show you 171 angstroms. Northern hemisphere of the local yellow dwarf. And here's a close-up of Sunspot 2810 before we close things out. First 193 angstroms. I'll let it play through a second time for your viewing pleasure. Great view of that. And here it is in 171 angstroms. Thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, don't drink. But if you do, don't drive. Welcome to the Neo-Renaissance, and since it'll never be now again, may that solar wind be at your back.